Okay, so this lecture is going to be about the Gay-Lusac's law and the combined gas law. There are two scientists. These are their last names, Gay and Lusac's. They came up with this law, and what this law said is that if you increase the temperature of a system, then the pressure is going to increase, assuming that these volumes are constant. So if you look at the boxes, they remain the same. The volume is the same, but when you increase the temperature, you have a higher particle kinetic energy, and because of that, you have a higher pressure because more molecules are colliding with the container. So what they found was that as the temperature went up, the pressure also went up, or when the temperature goes down, the pressure will also go down as well. So it showed a directly proportional relationship. And as a result, you would see a straight line on a graph going upward this way. So if you increase both, if you increase one, the other one goes up and you see a straight line. Or if one goes down, then the other one goes down and you would see a negative slope here on this side. But you always see a straight line, a relatively straight line. In terms of the formula, this would be the formula. P1 over T1 equals P2 over T2. The temperature tends to be at the bottom. So this first example right here, it says you have a spray can with this pressure and an initial temperature at this. Compute the internal pressure when the gas reaches a temperature that's really much higher. So what is the pressure when increasing the temperature by almost 20 times more its original temperature? So when you look at this question, it doesn't mention volume, so you're going to assume it's constant. So we're going to be using the formula that relates pressure and temperature. So we're going to write it down. It's P1 V1 equals P2. Oops, I think I messed up the formula. Let me start over. So the formula is P1 over T1 equals P2 over T2. And it says compute the internal pressure. So we're assuming it's P2. When you multiply T2 here, you have to do that to the other side. So your new formula is going to be T2 times P1 over T1. So T2 is going to be 873 Kelvin. So I got that by adding 273 here to make it Kelvin. And then P1 is going to be 1.5 ATM. And T1 is going to be 273 plus 20, which is 293 Kelvin. So that's the relationship that you need in order to find P2. And then P2 is going to equal 4.47 ATM. Okay, so that's your answer. Okay, so the next example is a conceptual question, and what it's saying is that if you get a glass bottle like this and you put a little bit of paper in there, you're gonna boil an egg and you're gonna remove the shell and you're gonna put the egg on top, and what you're gonna do is you're gonna set the newspaper or the piece of paper on fire, and you're gonna put it inside, and then the egg is gonna be placed on top. And after you do that, the egg on its own, it starts to get sucked into the bottle, and eventually the egg falls in. And the question here is why? So why does that happen? So you guys could try that at home. We could do that after the AP exam, but in terms of this, why does the egg fall into the bottle? So if you want to pause it and think about it for a minute, here is the explanation. And again, this is chemistry, so we need to talk about things at the molecular level. So if you draw, let's say this is the bottle, and you put an egg on top, and then you have a flame inside, you guys know that the oxygen levels are going to decrease. And when the oxygen levels decrease, you have less collisions. So the particles are not colliding as much with the container because the oxygen is being used up. You have less oxygen molecules inside, so there's less collisions and there's a lower pressure as a result of this, meaning that the pressure on the outside will be higher. So we have a higher pressure on the outside compared to the inside. So that's going to cause the egg to be pushed down into the container because the outside pressure is higher. So it's going to force this egg to go into the container. And that's why that happens, because there you have a difference in pressure, and because you have a difference in pressure, you're going to have a force going in a certain direction, which in this case would bring the egg down. Okay, so the next topic that we're going to talk about is the combined gas law. So if you connect Boyle's law, Charles's law, and Lusac's law together, meaning that you incorporate pressure, volume, and temperature, all three variables together, you come up with something called the combined gas law. So you incorporate three variables instead of just two. So instead of two things changing, now it's three things that are changing. So the pressure changes, the volume changes, and the temperature changes. And the new formula is P1V1 over T1 equals P2V2 over T2. So the first question says, how do you solve for T2? Let's say you have a pressure, you have a volume, you have a temperature, but then the pressure changes and the volume changes. How would that affect the temperature? Well, you have to solve for T2. How do you do that? Well, you guys have to use something called cross multiplying in order to figure that out. The way you do that is whatever is on this side, you multiply it to this side, set that equal to whatever's on the other side. So this side and this side right here. So we're going to start with P1 V1 times T2. So P1 V1 T2 is equal to whatever's diagonal on the other side, which is P2 V2 T1. We want T2, so we want to isolate this. And the only way to do that is to get rid of whatever's here and put P1 V1 there. Then you're going to plug things in. So T2 is equal to all of this, but we don't have numbers, so this would be our answer right here. Okay, so that's going to be our answer. Example 2 has numbers in it. I'm going to do example 2, and then you're going to try example 3, and that's how we're going to end the podcast. So example 2 says, it says a child opens the door to an airplane. If a sealed bag of Lay's had a volume of 450, so I'm going to write that down. V1 is equal to 450 and the temperature of 22. So the initial temperature is 22 plus 273 because we want to make it into Kelvin, and that's going to give us 295. So 295 Kelvin. There it is. And then it says that the it has a pressure of 0.95. And then after that, it says, what will the volume of the air in the bag of chips be? So we're trying to find the volume. So V2 is equal to what? And then it says that the temperature goes from 295 to negative 40. So when you add negative 40 plus 273, you get 233 Kelvin. So all I did is I added 273 to that number. And then it says that the pressure drops to 0.25, so P2 is equal to 0.25 atm. So now what we're going to do is we're going to write our formula down. So our formula is P1 V1 over T1 equals P2 V2 over T2. And again, we're going to cross multiply. So start with this side. P1 V1 T2 equals P2 V2 times T1. And we want the volume at the end. So we want this, so we're going to divide by whatever's next to it and put it on the other side. And now that we have our formula, now we just plug things in. So I'm going to write it right here. P1 is 0.95 atm. So if you do this right here, it makes things easier. You just plug it in. V1 would be 450 milliliters times T2, which would be 233 Kelvin, over P2, which is 0.25 atm, times T1, which is 295 Kelvin. And multiply this times this times this, and then divide by this and divide by that, and you end up getting 1,350 milliliters. It's milliliters because this volume's in milliliters, so we know that that's going to be the units. Now you try example 3 and see if you could get a large number. So for number 3, let me erase this. For number 3, you should get this as your answer. So 4 times 10 to the 28 atmospheres. Okay, so again, use your formula. P1 V1 over T1 equals P2 V2 over T2. It says, what will the pressure inside be? So we're looking for P2, but first we need to cross multiply. So P1 V1 T2 equals P2 V2 over T1, and we want P2, so whatever's next to it, you get rid of it, and you get this formula. Plug all your numbers in, and you should get this answer. Okay, and that concludes the podcast for this section.